Yeah, I think that's a pretty good angle. I tell you what, it's 8 minutes to 5, and I'm out here doing a few things. Have a little sip of coffee and show you a couple more things. Now that's a good cup of coffee. Okay. Now, I'm going to show you, try to kind of pull it together of how I get this machine to perform. But it's almost impossible, to do everything and squeeze it in. But I just kind of run over. Then if you're interested later on, you can watch me use the machine, and I'll talk about what I'm doing, and I can refer back to these few videos, okay? So let's get with it a little bit. I'll show you a few things and how to hold the close tolerance, which is, it better be 2 10,000ths or better to fit those Barton bearings. Okay, get this thing off the tripod. I just hope you're all fine and dandy. Okay, so for smaller parts, this is the rig I use here. So I fabricated this chuck. I talked about it a little bit. It's made out of pre-hard 4140, 5C collet chuck. I got a 3/4 inch collet in there holding a piece of hard steel. I fabricated the hand wheel. Now, in my experience in testing, the lever collet closers cause problems on this machine. And I found it on the hard inch machine too. I found to get the best accuracy, a standard hand wheel. Now, I custom fabricated this to work with the adjustable chuck. For a thrust bearing, it has a single tension bearing that'll allow a little bit of shift to correct for any problem with the collet, getting the collet run true. But the one thing about this, I'm running this thing at full speed nearly, and I'll talk about that real quick too. This entire thing, the chuck, of course, the work, and this hand wheel assembly has to run better than 2 thousandths. If it doesn't, it'll cause vibration like at 3,800, 4,000 RPM, and it'll cause the workpiece to be larger on the end, that taper. Larger on the end, tapering back to the work holder. Okay, everything that goes wrong makes the part larger on the end. And we're starting to get down into the tenths of thousandths when I'm talking larger on the end, okay? Now, an interesting thing, and you should check this out, I can, and you should be able to see something spinning like at 500 to 4,000 RPM that's running out 2 thousandths. 2 thousandths run out, it's sort of like a baseline. Anything over 2 thousandths, and you're going to have problems with vibration. It's just the way it is. So everything has to run better than 2 thousandths. And that includes the chucks. I got this 4-jaw chuck here. And this is the next step up. I actually found that with this machine, this setup, when I start getting bigger than 3/4 inch, I'll switch to this chuck. Small as possible 4-jaw chuck. Now this chuck here, I want you to look at it. It's an antique, and it's a Skinner 904. And I think it's about 4 1/4 inch diameter. But look at the jaws on this thing. Look how thick they are. Now, this chuck here is one that I chopped down, shortened the screws, moved them inward, and also enlarged the bore. This was a damaged chuck here. It was an 8-inch standard Monarch direct mount chuck, but now it's a custom chuck. You see the jaw width? This is a 4-inch chuck, and these jaws are wider than the Monarch 8-inch chuck. This chuck here is not designed to offset parts. This chuck is designed to hold parts true and solid as a rock, and I haven't found a better chuck than this one here. And until, for the next size up was 6-inch, and I found those kind of a disappointment. Then I got lucky and found this junked up 8-inch and chopped it down to 5 3/8 inch, had it dynamically balanced. And you can see where I shortened the jaws right here. See how short that part is compared to these parts. So that's how I did that. Then within the capacity of the chuck, you're going to run into another problem. When you kick the thing up to about 4,000 RPMs, the jaws start chopping the air and it starts buzzing. The buzzing causes the part to be larger on the end. So that's why I have the jaws tucked in here. Now, I found the capacity of the machine to be under 3 inches as far as holding super close tolerances. Okay, so there's a capacity that I found. You move up to another machine. And one logical choice years ago was a Morisiki. Seemed to be a good chunk up, for a number of reasons. Well, okay, hold on a second. Where's that coffee? There it is. Haven't had enough coffee yet. Yeah, that's it. Okay. Now another thing. Every little detail, and I've talked about this before, you got to find the highest speed that the machine's going to run good at. And so what I do, and it's not safe, and I got to point out another safety hazard here too, what I'm doing is really dangerous, and it's that hand wheel, is I adjust the belt with it running at 4,000 RPMs. Yeah. I adjust it until it runs as smooth as possible at 4,000 RPMs. Then I found on this particular machine, here's my vary, that it runs glass smooth at 3,800 RPMs. So that's the speed that I target at. And I've talked about how that centrifugal, there's a centrifugal force, and then there's a gyro effect that helps reduce the tool pushing the work over, which is reduced by an aggressive tool angle, a small radius, small feed, small depth of cut. Okay, now I'm going to jump. I'm going to point out this because it's dangerous. You've got to really be careful. And this is why you can't buy these anymore. Now, these hand wheels here, if this thing's spinning, and particularly this one I made, it's knurled, but it doesn't matter. If this thing's spinning 4,000 RPMs and you get your clothes caught in it, it could kill you. And there's another hazard with these, and what I'm doing too is, you see these holes here? I can put a bar in there and snug a collet as tight as I need it to be. But that can be a hazard too because it can break off. And if this thing's running at 4,000 RPMs and a collet snaps off while you're working at it over there, this drawbar can eject out of the machine and fly around the room like you wouldn't believe and could kill you. So when I run this machine like this, I have this vise here, and I have a piece of steel here that I can put in that vise, lock it up tight so to keep that from kicking out. In my other shop, I used to roll my snap-on toolbox up here to catch it, for that. Not everything's safe. Okay, you might say, where does he come up with all that stuff? Well, this is old secret stuff, but it was published at one time, and it was on the internet that you can't find anything else about except Madonna and weird crap like that. But it was the instruction manual for the Ramicron sold by Kennametal boring head system. And it says everything that I tell you about, and even add to it. And in the most funny ways, they guarantee, now this on for jig boring, their boring head system on CNC, jig boring centers, and jig borers. And I actually had a kit of those. I'll talk about that sometime later. Well, I had to kind of move on from those because I couldn't afford the inserts. They're high shear inserts that were extremely expensive. So I used the kit until I ran out of inserts. I found out how much they are, and I go, man, I got to get rid of this thing, and traded it off. And went back to just grinding my tools. The insert thing like that is really for big production outfits with bigger budgets, than Dee in his garage. But see, I can hit those tolerances just with having the tool and cutter grinder, and even with a bench grinder, just taking time and making a decent tool. But it's certainly not production. Anyway, that way. So let's get back to the instructions in the Ramicron boring head system. What they tell you to do is to do the finish cut. And get this, they guarantee an average operator can reach, it's kind of unclear, either plus or minus 80 millionths of an inch, which is the maximum tram on a more jig bore, or 80 millionths of an inch. The average operator can get 80 millionths of an inch by using the Ramicron boring head system. And they go into stuff. Of course, the temperature should be 20 degrees centigrade, 68 degrees Fahrenheit, how precision machines are. You want to try to get that close when you have these kind of machines. Okay, back to how they say to do it. Well, you take two cuts, finish cuts. You take, and I'll show you here. Now, what I do is I rough the part with the standard, these are TMMG 221 inserts. I rough the part down with them. Then, hold on, I need more coffee. Oh, bear with me. I don't know, maybe I should just turn off the camera and drink coffee, huh? Okay. So I get the part roughed down with this, right? But the pressure of that negative rate insert pushes the work over. It's bigger on the end, okay? Maybe in this length, it could be up to a thousandths of an inch, just kind of doing it. So on the finish cuts, I mentioned before that the tool's good for 2 or 3 cuts. Well, after I make 2 finished cuts on one, I take and move it to another holder. And this, I call this the straightening up cut. So you got a bunch of taper from this roughing tool, shoving the work over. Take a tool that you ground and already cut something with, but it's still sharp enough. Take a cut that helps remove most of that taper. Then you move in the killer, deadly sharp, fresh tool. Take a cut. Now, I'm telling you, at this point, I want 6 thousandths, because I'm going to plunge in on average 1.5 thousandths. I want 6 thousandths over. So I touch it, hit it 3 thousandths or 2.5 thousandths, back it off, put the gauge on it, and then dial in what I need to do last cut. And it's always right on. So there's actually 3 finish cuts after roughing. You got to do a cut to take that taper out from roughing. And then you go into the 2-step deal with the Romicron. Now, what they're saying with that boring head system, like on a jig boring, CNC jig boring center, of course, it's going to rough the hole out with something like a Criterion boring head or something, you know, rough it out, and then that use that Romicron head and to get to 80 millionths of an inch that they guarantee. And, you know, you see the nonsense on the forums and stuff like, that's impossible to even measure. Well, Sonnen doesn't think so, and industry doesn't think so. Now, what you got to do to measure really close tolerances, like when you're working with the bearings and stuff, is have a decent set of gauge blocks and set your tools very close to the diameters you're working with, and you'll be okay. I'm telling you, you'll be okay. So that's pretty much it. You know, it's not that hard, but there's an awful lot of preparation, you know, with the manual machine and that pushover, you know, where it causes that taper. And once you figure out how to get that taper, using, and the Romicron system talks about a very fine feed and a very shallow depth of cut. With I think the maximum on some of those cutters was like 14 thousandths depth. But you have to consider, like a CNC jig boring center has really a lot of horsepower and a heavy duty spindle. And we got a little bit of a flexibility thing going on here with the ball bearing spindle on the Monarch 10EE. So you just got to kind of play around. So, and test. You got to test your stuff. And I found that scroll chucks are just totally out of the question when you're doing something like fitting bearings. The problem with them is at the speeds and the clearances needed for a scroll chuck to work, the part will shift every time. It just can't help but do that. The scroll needs a couple thousandths at least to rotate inside the chuck. The jaws need some play. There's play on the scroll. There's tilt. There's all kinds of things going on there that show up when you spin that thing up. Like I've shown with that old Buck 6 jaw. Spun it up over 2,000 and it stretched enough to let go of a bushing. That's not a good work holding system, but a handy tool for thin wall stuff. Okay, chew on that stuff a little bit, and man, I got It's 20 degrees outside, just terrible. So I'm going to get another cup of coffee and see what happens today. Not kidding you. I don't know what the weather's going to do. I'd like to get that press in here and do that Acme thread. I think that's going to be a lot of fun. Okay, bye.